Mastering KPIs and metrics for modern software development. Velocity and throughput metrics are meaningless without accountability. When evaluating the productivity and efficiency of our development teams, how do we effectively track and measure their velocity and throughput to ensure optimal performance and continuous improvement? Tracking and measuring the velocity and throughput of development teams is crucial to evaluate their productivity and efficiency. Velocity and throughput are key metrics that help organizations understand the development team's capacity, identify bottlenecks, and make data-driven decisions to optimize their performance. Here's how to effectively track and measure velocity and throughput to ensure optimal performance and continuous improvement. Define and track cycle time. Cycle time is the time taken to complete a user story or issue from start to finish. It's a critical metric that helps identify inefficiencies in the development process. Calculate cycle time by tracking the time taken to complete each task, from the moment it's picked up by the development team to its deployment to production. This metric helps identify bottlenecks, such as prolonged testing or review phases, and enables teams to optimize their workflows. Velocity. Velocity measures the amount of work a development team can complete during a sprint or iteration. It's typically measured in story points, ideal days, or t-shirt sizing, small, medium, large. Velocity helps teams estimate the capacity for future sprints and identify areas for improvement. To track velocity effectively, establish a consistent unit of measurement, e.g., story points, and ensure the team understands how to estimate tasks accurately. Calculate velocity by summing up the estimated points completed during a sprint. Track velocity over time to identify trends, such as increases or decreases in productivity. Use velocity to inform sprint planning, ensuring the team is not over or under committing to work. Throughput. Throughput measures the number of tasks, user stories, or features completed by the development team within a specified time frame, e.g., sprint, month, quarter. It helps teams understand their capacity and capacity utilization. To track throughput effectively, define a standard unit of measurement, e.g., tasks, user stories, features, and ensure consistency across the team. Calculate throughput by counting the number of completed tasks or features during a specified time frame. Track throughput over time to identify trends, such as increases or decreases in productivity. Use throughput to identify bottlenecks and optimize the development process. Lead time and lead time distribution. Lead time measures the time taken for a task or feature to move from the backlog to deployment. Lead time distribution helps teams understand the variation in lead time and identify areas for improvement. To track lead time effectively, calculate lead time by tracking the time taken for tasks or features to move from the backlog to deployment. Create a lead time distribution graph to visualize the variation in lead time. Analyze the graph to identify patterns, such as outliers or skewness, and optimize the development process accordingly. Code churn and code quality. Code churn measures the percentage of code rewritten or refactored during a specified time frame. Code quality metrics, such as cyclomatic complexity and code coverage, help teams understand the maintainability and reliability of their codebase. To track code churn and quality effectively, calculate code churn by tracking the percentage of code rewritten or refactored during a sprint or iteration. Use code quality metrics, such as cyclomatic complexity and code coverage, to measure the maintainability and reliability of the codebase. Analyze code churn and quality metrics to identify areas for improvement and optimize the development process accordingly. Deployment frequency and deployment lead time. Deployment frequency measures how often the development team deploys code to production. Deployment lead time measures the time taken to deploy code to production after it's ready. To track deployment frequency and lead time effectively, calculate deployment frequency by tracking the number of deployments to production during a specified time frame. Calculate deployment lead time by tracking the time taken to deploy code to production after it's ready. Analyze deployment frequency and lead time to identify bottlenecks and optimize the deployment process accordingly. mean time to recovery, MTTR, and mean time between failures, MTBF. MTTR measures the time taken to recover from failures or incidents. MTBF measures the time between failures or incidents. To track MTTR and MTBF effectively, calculate MTTR by tracking the time taken to recover from failures or incidents. Calculate MTBF by tracking the time between failures or incidents. Analyze MTTR and MTBF to identify areas for improvement and optimize the development process accordingly. Visualization and feedback. Visualize the tracked metrics using dashboards, charts, and graphs to facilitate understanding and facilitate data-driven decisions. Provide feedback to the development team on their performance, highlighting areas of improvement and recognizing achievements. Regularly review and refine the metrics and tracking process to ensure it remains relevant and effective. By tracking and measuring velocity, throughput, cycle time, lead time, code churn, deployment frequency, MTTR, and MTBF, development teams can gain a comprehensive understanding of their productivity and efficiency. This enables teams to identify areas for improvement, optimize their workflows, and strive for continuous improvement.